Command Query Responsibility Segregation, or shorthand CQRS, is a software architectural pattern that separates the concerns of reading data, queries, and writing data, commands into separate models. The core idea behind CQRS is to have different models and approaches for handling read and write operations in a system, rather than combining them into a single model. In traditional architectures and CRUD systems, the same model is often used to handle both read and write operations. However, as applications grow in complexity, the requirements for reading and writing data can diverge significantly. This can lead to issues related to performance, scalability, and maintainability. With CQRS, the application's data model is divided into two separate parts. The command model, which handles write operations, aka data modification. This model enforces business rules and validation logic to ensure that data changes are correct and consistent. And the second being the query model, which handles read operations, aka data retrieval. The query model is optimized for reading data and often involves denormalized data structures or specialized views that cater to specific read use cases. This separation allows for efficient querying and improves the overall performance of the read operations. The CQRS approach offers several benefits, such as performance. It allows us to optimize the read and write operations independently. For example, we can use different data stores for the read and write models. This allows us to choose the right tool for the job and optimize the data stores for their specific use cases. Scalability. CQRS lets us scale the read and write operations independently. For example, a nice use case is a flight booking system, where the read operations are much more frequent than the write operations. And lastly, maintainability. CQRS allows us to evolve the read and write models independently as well. However, like anything else in the engineering world, CQRS also comes with some drawbacks, such as complexity. CQRS certainly adds an additional complexity to a system, making it harder to understand and not suited for simple applications. And also, eventual consistency. The read and write models are typically eventually consistent, meaning that the changes made to the write model are usually not immediately reflected in the read model. While this isn't a drawback per se, it's something that we need to be aware of when using CQRS. CQRS is also used in combination with event sourcing and event-driven architectures, both of which we'll dive deeper into in future lessons. In the next lesson, we'll take a look at how we can implement CQRS in our very own application. Let's get started.